Oh, won't you? Oh, won't you so bad?
Good afternoon, my name is Pablo Galindo, and today I'm going to speak about bioremediation, pollution, water treatment process, and the use of bioremediation in water treatment and pollution.
Oh, won't you? Oh, won't you so bad, baby? Oh, won't you?
In an unpolluted environment, bacteria, fungi, protists, and other microorganisms are constantly at work breaking down the organic matter. What would occur if an organic pollutant such as oil contaminated this environment? Well, some microorganisms would die, but others are capable of eating the organic pollution and they will survive. And that's why bioremediation works by providing these pollution eating organisms with fertilizer, oxygen, and other conditions that encourage their rapid growth. These organisms then will be able to break down the organic pollutant at a correspondingly faster rate. In fact, bioremediation is often used to clean up the oil spills. Pollution is the introduction of contaminants into the environment, and it is created mostly by humans, but it can also be the result of natural disasters. Pollution has a detrimental effect on any living organism in an environment, making it virtually impossible to sustain life. Pollution harms the earth environment and its inhabitants in many ways, and there are three main types of pollution. The land pollution, that is the pollution of the earth's surface by industrial, commercial, domestical, and agricultural activities. Air pollution, that is a pollution on the earth's atmosphere that endangers human life and other living things. And the water pollution, that is the introduction of chemical, biological, and physical matter into large bodies of water that degrade the quality of life and that lives in it and consumes it. Water may be treated differently in different communities depending on the quality of the water which enters the plant. Groundwater is located on the ground and typically requires less treatment than water from lakes, rivers, and streams. There are 5 steps of the water treatment process. The first one is coagulation, and it is to remove dirt and other particles that are suspended on the water. Alum and other chemicals are added to the water to form tiny sticky particles called phloc, which attract the dirt particles. The combined weight of the dirt and the alum become heavy enough to sink to the bottom during sedimentation. Second step is sedimentation. The heavy particles settle to the bottom and the clear water moves to filtration. The third step is filtration. The water passes through filters that help remove even the smallest particles. The fourth step is disinfection, and a small amount of chlorine is added or some other disinfection method is used to kill any bacteria that may be inside the water. And the last step is storage. It's when the water is placed in a closed tank and then the water flows through the pipes to homes and business in the community. European researchers had investigated the possibility of using naturally occurring microbes to biodecontaminate groundwater, a source of organic solvent pollutants in surface water. The next step was then to increase the pollutant removal activities and sustain these processes, as well as develop tools to investigate microbial degradation and to increase the bioremediation potential of the community. The scientists investigated the effects of changing variables like nutrients and electron donors and receptors. Surface water contamination from degreasing activities in industry is a significant problem with their appearance concentration that they are harmful and carcinogenic. Well, that's all for today. Thanks for listening.